In the next problem we have f of x is equal to the square root of 1 minus sine of x, and again we're looking for the domain of f. And once again, a radical function will be defined wherever its radicand is greater than or equal to 0, or the square root function in this case is defined wherever square 1 minus sine of x is going to be greater than or equal to 0. And that is whenever sine of x is less than or equal to 1. But since sine of x is always less than or equal to 1, then that means that the domain of f will be all real numbers, because it's always true that sine of x is less than or equal to 1. The next thing that we want to do then is to find the derivative of the square root of 1 minus sine x, and that would be the same as the derivative of 1 minus sine x to the 1/2 power. And so that'll be a chain rule. The derivative of the outside would be 1/2 times the quantity 1 minus sine x to the negative 1/2 power. Then we have to multiply that by the derivative of 1 minus sine x, which is negative cosine of x. And that completes that. So I'll just simplify that a bit. And so we'll get negative cosine of x divided by 2 times the square root of 1 minus sine x, and that is f prime of x. And again, the question is asked, what is the domain of f prime of x? Well, f prime of x will have the same domain because this derivative will be defined wherever its denominator, since cosine in the numerator is always defined, or defined for all real numbers, the derivative will be defined wherever the denominator is not 0. So actually we have to take the denominator, especially the radicand, and solve it for 0. Since we have shown that 1 minus sine x is always non-negative, so we don't have to worry about the negative values under the radical. But now, since it's in the denominator, we do have to worry about zeros under the radical. So that that denominator will be 0, and the derivative won't exist whenever sine is equal to 1. And that will happen when x is pi over 2, and since we have no restrictions on the domain here, it would be pi over 2, 5 pi over 2, 9 pi over 2, etc. You could do the k thing here and write an expression using k that would define this, but this is fine. X is equal to pi over 2, 5 pi over 2, 9 pi over 2. The progression is fairly straightforward and easy for anyone to follow. So those are the places where the derivative will not be defined. Finally, we want to write an equation for the line tangent to the graph of f at x equals 0. Once again, x is equal to 0. We plug in 0 into the original equation and we'll get y is equal to 1. Then for the slope of the tangent line, we're going to plug in 0 into the derivative function. In the derivative function, we will get 2 in the denominator, and we will get negative 1 in the numerator. So we should get a slope of negative 1/2. And since x is 0, the x sub 1 is 0, we're going to get y minus 1 equals negative 1/2 x, or y equals negative 1/2 x plus 1. And that completes this problem.